Good morning students. In today's class, I am going to teach you other type of cycloid, that is Epi Cycloid. What exactly Epi Cycloid is? In previous class, Introduction to Cycloids lecture, I have taught you what exactly a cycloid is. But in today's class, in other method that which we are going to discuss today is Epi Cycloid. What Epi Cycloid is? As per the definition of cycloid, it is a curve traced by a point when a circle is going to move on a fixed straight line for one complete revolution. That is nothing but cycloid. In cycloid, there are three types. One is general method, epicycloid and hypercycloid. What an epicycloid is? For example, before going to start, I read out the question which I have written here on the board. A circle of dia 40 rolls on the circumference of another circle of dia 140 for one complete revolution without slipping. Draw the curve and name the curve. Also draw tangent and normal at a distance of 80 from the center of directing circle. I told in the last class this question relates to what type of curves, whether it is a cycloidal curves, whether it is an involute or whether it is a conic section. I told you to find out some words or hints from these questions. Like, when you look at the word without slipping, it belongs to cycloids. And I even told you one complete revolution or a complete revolution, or the words or terminology like directing circle. Directing circle. Now, before going to work on this problem, if you look here, a circle of dia 30 is given and another circle of dia 140. What is this? A circle of dia 30 is going to roll on a circle of dia 140. Now let's work on what exactly epicycloid is. I have a circle, a bigger circle. This is nothing but a directing circle. Upon the circumference of this directing circle, another one more circle is going to roll. This is nothing but my generating circle. The terminology for this is a fixed circle and this is a moving circle. The fixed circle is also called as directing circle, whereas the moving circle is also called as generating circle. So what the question asks here is, the 40 diameter circle is going to roll upon the surface of the circumference of 140 diameter circle. This is what? This is nothing but the applications of gate teeth meshing. One gate teeth meshing in the other gear is application concept for the mechanical engineers. What is going to happen here is, I am going to trace the curve like this. So I am going to get a cycloidal curve, cyclic nature, when this circle is going to move on the circumference of another circle. So when it is moving upon the another circle, it is termed as epicycloid. Now let's work out a geometry construction, how to work on this problem when it is like this. Now, first what you are going to do here is, one circle that is nothing but generating circle of dia 30 is given and directing circle, another circle is nothing but here, the directing circle or the fixed circle, that dia is 140. That means its radius is 15 and this radius is 70. So generating circle is of radius 15 and the directing circle is of radius 70. And what else is given in the question is also to draw tangent and normal at a distance of 80 from directing circle center. 80 from directing circle center. This is what we are going to work out in today's class. The first thing is, locate a point anywhere in your drawing sheet and naming it as something O or O dash. Locate a point on your drawing sheet and naming it as O dash. O dash as center, radius is directing circle radius, that is 70. First I am going to draw the larger circle with radius 70. I am going to plot a curve. This has center, draw with 70. Just instead of drawing a circle, you just draw a semicircular part of the circle. Then arc with radius, this radius are 70. Now from O dash, draw another line either left or right onto the curve touching it of any angle. Just draw a line onto this curve of any angle and extend it out further. Extending it out further. How much I need to extend further is, why I am drawing this line is to locate a generating circle. To locate a generating circle. How much is that? R15. Radius 15. So upon this, the more circle is moving. So that's from here. I need to take a distance of 15. So this is my point. From here, draw a line of 15. That means this is P, my initial point, and this is O. PO is 15, R15. Now PO as radius, O as center, draw the circle. Draw the circle. What I have done? From O dash, draw a line meeting this R, extend from here R 15. Why? Because my generating circle radius is 15. So P is my initial point and O is the center. Now, as per the definition, a cycloid is a curve which is going to roll on a fixed straight line or a fixed circle for one complete revolution. So till where it has to move, as till what point it has to move, we need to locate the final position. As is my initial point, where is the final point where it is going to end. Then how to calculate it is, I have a theta value, angle of the curve, that is radius of the generating circle to that of radius of the directing circle into 360 degree. Into 360 degree. I know my radius of the generating circle is 15 and the radius of directing circle is 70 into 360 degree. Dear students, using your calculator, you can find out this value. So whatever the value you get here, taking the compass, placing your compass on O dash and mark it, then join the end line. This is my path where I am going to trace within this limit my cycloidal curve. That means still here, from here to here. So this is my point B. B is the directing circle arc. Now, from where I am going to start initial point and where I am going to end my revolution or rotation of the circle. Next, it is similar to that of generating circle, directing line, the terms which we studied in general method. But whereas here, instead of circle, instead of a line, a directing circle. The remaining all the steps are similar to that of the last video which I have done on general method. Like if you remember, after locating a PB, then we divided the circle. We have divided a circle into 12 equal divisions. Divide the circle as well as divide the directing circle into 12 equal divisions. I am going to divide this into 12 equal divisions. I hope you have gone through my video on how to divide a circle into 12 equal divisions. So using that method, students, you have to follow here also, like how to divide a circle in easy method into 12 equal divisions. Similarly, you are going to divide arc also into 12 and that same equal number of divisions. You know how? You got an angle here. So whatever the angle you got here, that will be divided by 12. You will be getting a value. Whatever the value you are getting, placing your compass, taking your compass and draw circle or just then marking the 12 divisions. whatever the angle you get, put your pro-circle and find out the angle, 12 points, whatever the value you get divided by 12. So those divisions you are going to mark here a points like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12, so on. Now from O dash, project this all onto PB line. Project this all onto a PB line. We are going to draw a thin lines which will be of equidistance when you work out with the pro circle after dividing. So when you do it exactly with the help of instruments, you will be getting equidistance. Where students, as I am not using the instruments, my drawings are not to the scale. This is only just for understanding. I am going to teach you on the board without using the set of instruments. I hope you are going to work out using a pro circle and divide these all lines, the points, into 12 equal divisions. So this is what? So this is my 1 and this is 12. P is 12 and this is 1. So similarly you can write down all the numbers next. If you remember in the general method, we have even traced the locus of center of the circle. What is the locus of center of the circle? Now, why the locus of center of the circle? Taking that as center, we are going to trace the curve. What is that? O dash is the radius. O dash is radius. My O dash is center. O dash is center. O dash is radius. With your engineering compass, O dash as a center, draw an arc. Draw an arc. That is nothing but locus of center. A line passing through center of the circle and parallel to directing circle. And parallel to directing circle is nothing but locus of center or locus of circle. This is what. So this is my something OA, let it be. OA is my locus of center. What I am going to do the next here is I am going to project these all lines onto locus of center. Just erect them onto it. Kindly work out using drafter, engineering drawing, all the curves. Do not use plane scale because you may not be getting exact line. I mean to say the parallel or the perpendicular or whatever the lines you are going to draw on your drawing sheet, you may not be getting. So similarly, I will write alternate numbers. Example, this is 2, 3, 4, 5, 6, 7, 8, 9, 10 and this is my 11 and 12. So alternate numbers can be also written. Now dividing even the circle also into, as this is my initial P point, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, so on. What exactly is OA? OA is locus of center. So I am going to, as the circle is going to move on the circumference of another circle, its center position is not at all going to change. So that's the reason. So this is my O1. This point, as this line is 1, it is erected here. So this is O1, this is O2, O3, O4, O5, O6, O6, 7, this is 8, and this is 10, this is 11 and 12. I hope you remember even the general method also. From the directing line, we have erected straight lines from the center of the circle. We have drawn a line locus of center and located all the centers. Now, the similar procedure that of general method. Now I am going to rotate this circle on the circumference of the directing circle. The smaller one, the smaller circle of radius 15 is going to be moved on the circumference of this big circle. Before that, I need to trace arcs or the lines from each division for my construction. As if you remember the video of general method. Now, O dash as center center, like 1 and 11 dash, or just 1 and 11 as radius from where O to 1 dash. O dash to 1 is radius, that O dash to 1 is the radius. I mean to say O dash is the center. With your engineering compass, take your compass, needle and pencil, placing it on O dash 1, you will be getting the radius. Then draw the arc, curve, which are parallel to directing circle. Directing circle. Now again O dash and 2. O dash and 2 is the radius, O dash is the center. Then 2 and 10 will be on this line. 2 and 10. Dear students, if you are not getting this video, please go through the general method video which I have shared with you already. Then O dash 3 is the radius, so 9 and 3. 9 and 3 will be on this line. So this is line 9 and 3. Next O dash 8 is the radius, then draw an arc. These all are thin lines of general construction. Next O dash 7 is the radius, O dash as the center, draw an arc, a curve. Next the final is 6, O dash 6 is the radius, O dash C, O dash as the center, draw an arc. So that you will be getting all set of arcs or the curves, these all which we are going to trace from the circle for our general construction method. Next. Now when this circle is given tilt or the rotation without slipping from one complete revolution on the circle, then how the process work out is. As my locus of center will act as center, I mean to say O1, O2, so on, O12 are centers. Radius is 15, the smaller generating circle. As generating circle is moving on it, so radius is 15. Taking radius is 15, and O1, O2, O3, so on, all are the centers, cutting the respective lines. What I am telling here is radius is radius of the circle. O1 as the center, cut the first line. Where is the first line? 1 and 11. So O1 first line with radius 15. Next take similarly O2 center, cut second line. This is second line. So these are my points P1, P2. So O3 third line, O4 fourth line. Similarly go on cutting all the lines. Next O7, again it will come down here 7, O8 8, O9, where is my 9? Here is 9, and O10 10, O10, O11, and O12. It will cut this. This is what, how you get till 12 you are going to cut all the marks. So those respective dots or the arcs on these curves are the points with respect to P1, P2, this is what P4, P6, so on. So these points we are going to join with a smooth curve from P initial position. First we trace dots from all this. Instead of drawing directly, when you locate dots and join these all dots, you will be getting a smooth curve. So dear students, now with HB pencil in single stroke, you are going to join all these dots without lifting your hand. In a single stroke you are going to draw this. You are going to draw this. So this curve is nothing but cycloidal curve, whereas it is moving on directing circle as it is touching. So we are going to even draw this directing circle also with HB pencil. So this is what our curve. It is moving like this. As it is moving, so this curve will be of this nature. So whatever I have marked in yellow mark is my directing circle, and this radius or diameter to be written compulsory without forgetting. Why? Because 2 dimensions are given, so 2 dimensions to be written. This is pi 30 and this is r 70. I hope you got this. Before that, ending the lecture, I need to even talk about the tangent and normal to be drawn from the center of the circle, from the center of the directing circle. Now taking your scale and measuring 80 where the arc is touching. Better we draw this side instead of drawing this side. Why? Because we have this circle. So take your scale and measure till where it is 30. For example, it is somewhere here 30. Sorry, 80. From the center it is asked to draw at a distance of 80. The tangent and normal. This is 80. That means it is somewhere here. Let I mark this is 80. So this is my 80. From the center of circle, draw tangent and normal. This is similar to that of the general method which I explained. So this naming it as M, this point as M. So M as center, radius is radius of the generating circle, cut the locus of center. Where is locus of center or locus of circle? That is OA, cutting locus of circle. That is something point C, whereas this radius is R15. R15. Then draw a line onto this directing circle and further extend it down parallel with these all lines. Extending it down. What I did? 80, locating point M from mass center. Radius is 15. Cut the locus of center. Drop it. Whereas the line is touching here a directing circle R, that is N. That is M. Then join. The line joining MN is the normal. The line joining MN is the normal, and perpendicular to MN is tangent. Perpendicular to MN is tangent. That is T dash. This is T dash is tangent. And please do not forget to write the value of theta or just the symbol theta here in this gap. Oh, that is theta. And you are going to calculate this value and writing it on your drawing sheet there. Then write even the name of this as this is Epi Cycloid. Epi Cycloid. Yes students, I hope you got this lecture, how to trace Epi Cycloid. For more videos, please click the bell icon.